You know that phrase, seeing stars? What does it actually mean? Because it could be that weird flash of light you get in your vision, or it could be the twinkle of a star millions of miles away. Well, guess what? We're going to tackle both.
I mean, think about it. You rub your eyes a little too hard and bam, instant light show. Or you stand up too fast and your vision just sparkles for a second. And then, of course, you look up at the night sky and see all those flickering lights. So what in the world connects these totally different things? That's the mystery we're going to unravel today.
All right, first up, let's talk about that light show happening right inside your own head. And no, this isn't about astronomy, this is pure biology. It's what's going on when your eyes send a signal that, get this, isn't actually coming from an outside light source at all.
Yeah, this strange experience actually has a medical name. It's called photoopsia. And basically, it's when your eye kind of tricks your brain into seeing light. It's generating its own internal signal even when you're in a pitch-black room. So, what does this photopsia actually look like? Well, it can show up in a bunch of different ways. For some of us, it's those classic stars. But for others, it might be shimmering spots, maybe some weird zigzagging lines, or even these vibrant flashes of color. They're all just different flavors of the same internal thing. Now, before you start to worry, I want to make something super clear. Most of the time, photopsia is completely, totally harmless. It's usually just your body's normal temporary reaction to everyday things.
Okay, so let's break down some of those harmless causes. When you rub your eyes, what you're really doing is putting physical pressure on your retina's light-detecting cells, and that makes them fire off. A really big sneeze or hard cough, that spikes the pressure inside your eye. And you know that dizzy, star-filled moment when you stand up way too fast? Yep, that's just a temporary drop in blood pressure, which affects how much blood is getting to your eyes for a second. Okay, but, and this is a really important but, photopsia isn't always harmless. Sometimes it can actually be a warning sign your body is sending you, a little flag that something more serious might be going on and you should probably pay attention.
So the big question is, how do you tell the difference? While the harmless flashes, they're typically really brief, they don't happen often, and you can usually link them to something specific, like rubbing your eyes. The warning signs, on the other hand, are different. We're talking about a sudden, persistent increase in flashes or seeing them right after a head injury. Or maybe you're experiencing them along with some vision loss or a really severe headache. That's when you need to listen up.
Yeah, if you see any of those warning signs, they could be linked to some serious conditions, like a retinal detachment, a concussion, or something called a migraine with aura. This is why any sudden change in seeing stars, a new pattern or it's happening a lot, that's always something to get checked out by a doctor. Don't mess around with that. Okay, so let's hit pause on biology for a minute and pivot. We've looked at the stars inside our eyes, so now let's take a journey like millions of light years away and look at the real stars in the sky. We're still talking about twinkling, but believe me, this is a completely different science.
All right, get ready for a little mind-blowing fact here. Stars don't actually twinkle. Seriously. If you were an astronaut floating in space, you'd see them shining with this steady, unwavering light. The whole twinkling thing we see, it's an illusion, and it's created right here in our own atmosphere.
And hey, just like photohapsia has its fancy medical name, twinkling has a scientific one too. It's called astronomical scintillation. Rolls right off the tongue, huh? It's all about how our atmosphere messes with the light from distant objects before it even gets to our eyes.
So how does this actually work? Well, the answer is literally in the air we breathe. It turns out we're looking out into the vastness of space through a thick, messy, and constantly moving window.
So don't think of our atmosphere as a clean, clear pane of glass. Instead, picture it like a lens made of all these turbulent, shifting layers of air, and each layer has a different temperature and density. It's way less like a window and more like, that wavy, distorted view you get when you're looking through the heat rising off a hot road in the summer? It's exactly like that.
So let's follow a little photon on its incredible journey. For millions of years, light from a star travels in a perfectly straight line through the vacuum of space. But then it hits our atmosphere. As it plows through all those turbulent layers of air, its path gets bent or refracted again and again and again. To our eyes, this super-fast zigzagging of the light path is what we see as a twinkle.
Okay, so here's a question you've probably wondered about. Why do stars twinkle, but planets like Mars or Jupiter usually just shine with a steady glow? The whole secret is distance. Stars are so incredibly far away that they're basically just tiny pinpoints of light from our perspective. It's super easy for our atmosphere to knock that single point of light around. Planets, on the other hand, are so much closer to us, so they appear as tiny little disks, not points.
It's been put really well this way. While the light from one edge of a planet's disk might be zigging, the light from the other edge is zagging. All those tiny movements kinda cancel each other out, which is why planets seem to shine with that steady, stable light.
And there you have it. The same simple phrase, seeing stars, actually describes two completely fascinating but totally separate things. One is a biological light show happening inside our own eyes, and the other is a massive atmospheric illusion that affects light that's traveled across the galaxy to reach us.
It really makes you think, doesn't it? From the pressure inside our eyeballs to the turbulence in the air hundreds of miles up, our entire perception of the world is constantly being bent and shaped by these invisible forces. It just makes you wonder, what else is hiding right there in plain sight?